So when we talk about viscosity, viscosity is basically all about liquid friction, like we have solid friction. Because liquid in general or fluid in general flows in different layers. So whenever there is a relative motion between the liquid layers, then a force comes into play. And that force is called viscous drag or viscous force. And this property of a liquid or any liquid, due to which opposing force comes into play whenever there is a relative motion between the liquid layers, is said to be viscosity. Now, the point is, in scientific way, this viscosity is very much applicable in daily life. Like it's winter is arriving now, so we are using some cold cream or something like that. While manufacturing, its viscosity is taken into account so that it can spread properly and easily. When it comes to the measurement of viscous force, for that, let us consider two liquid layers of certain surface area A having separation delta x or dx. And let's say topmost layer having velocity v plus dv and lower one or the next layer having velocity v. And if you can imagine that it is flowing from left to right side, then between the liquid layers, a force which is called viscous force or viscous drag comes into picture. And this viscous drag depends on some factor, which is the F proportional to the surface area of liquid layers. And it also depends directly on the dv upon dx, which is velocity gradient. When we combine them together, then we get F is equal to minus eta a dv upon dx. This becomes general formula for viscous force, where negative sign signifies that the viscous force acts against the direction of flow of liquid. And so far this eta is concerned, this is basically called coefficient of viscosity. What? Coefficient of viscosity. Okay. Coefficient of viscosity. Now let's find a unit and dimension of coefficient of viscosity, which is very important. Of this eta. If we cross multiply, we get eta as F into dx divided by A into dv. F we write in Newton, dx is distance, so meter, area is meter square, and dv means velocity. So velocity is meter per second. Okay. Velocity is meter per second. So second will go up, which means this meter and meter is cancelled, and thus we are left with the Newton per meter square into second. This becomes unit. We know Newton per meter square can be written as Pascal. So PA, Pascal into second, can also be its unit. Now let us find dimension. To find dimension F, so eta, which is F into dx divided by A into dV. F can be Newton, dx is meter, divided by area is meter square, dV is again meter divided by second. And now let's write in MLT. So Newton will be M is MLT minus 2. Then M is distance, so L. Second is T divided by M cube it is. So M cube means L3. So if this L3 will go up, it will be L minus 1 because L square is already existing. So it becomes M, L minus 1 and T minus 2 and T plus 1. So it is T minus 1. This is the dimension part. Now, if we are told to define the coefficient of viscosity, as such, we do not have any qualitative definition, but we can define it mathematically. So, definition of eta. To define this, we are using like for A is equal to 1 meter square and dV upon dx as 1 unity, then eta becomes F. And thus, we convert it into words as the coefficient of viscosity is equal to the viscous force when the liquid layers having unit surface area having velocity gradient 1. The coefficient of viscosity is equal to viscous force having unit surface area and velocity gradient 1. Thus, we define coefficient of viscosity. Now, we can apply this formula in questions and numericals. But before we come to question, let us have one more topic. And topic is Stokes formula. Stokes formula. When it comes to Stokes formula, basically Stokes explained that if we consider a spherical body of certain radius r, it can be raindrop, it can be any ball or anything else. And if it moves down, let's say with velocity v, then what will happen? Since it is moving through a medium, so it will drag all the medium particles along with it. Because it is dragging the medium particles, so what happens to the nearby molecules? They remain at rest. So there is a relative motion between the molecules of the medium. And due to that, an upward force comes into play. That force is called viscous force. Viscous force. F, let's write V. The Stokes give a relation that this viscous force depends on following parameters, which is 6 pi eta r Vt. 6 pi is constant, eta we know, coefficient of viscosity of the medium, eta. And Vt is called terminal velocity. As such, we do not have any mathematical expression for this formula, derivation for this formula, but we can check dimensionally which is correct, and so it is accepted. And then very significant point which is coming to be the terminal velocity. When it comes to terminal velocity, we know that if liquid or raindrop is falling through medium, initially their velocity is not uniform. But if you observe it carefully on the ground, then you may find most of the drops are hitting at the same time, which means they have constant velocity. So this constant velocity acquired by the spherical object moving through a viscous medium is called terminal velocity. Now, in equilibrium state, the weight of the object acts vertically down, viscous force vertically upward, and we know, as per Archimedes' principle, the buoyant force also act upthrust, vertically upward, buoyant force or upthrust. So we can write Fv plus u as mg, which means Fv is 6 pi eta rvt. Upthrust is basically equal to how much? The amount of medium particles displaced by the object. That applies upthrust. So let's take it. Mg dash is equal to mg, which means we write like 6 pi eta rvt. It will be mg minus mg dash. And so mass can be written as volume into density. So original, let's take this as sigma, or if you consider raindrop, then better to take rho. So inside we can have this rho and this raindrop having density rho and medium density having sigma. So for mg, it will be 4 by 3 pi r cube sigma g minus m dash g in terms of medium density, 4 by 3 pi r cube sigma g, which means 6 pi eta rvt is equal to 4 by 3 pi r cube common. So 4 by 3 pi r cube common means rho minus sigma into g. Now if we solve pi cancelled, then 2, 3, 2, 2 ja 4. And this r, so here it is r square. Now we are left with 3 sigma into Vt is equal to 2 by 3 r square rho minus sigma. Rho minus sigma into g. Now, if you do cross multiplication, then we get Vt is equal to 2 upon 9 times of eta r square rho minus sigma into g, and this becomes formula for the terminal velocity, expression for terminal velocity. Now we can think of few cases, like case 1, when rho is more than sigma, then Vt would be positive, and so the spherical object will come down towards the earth. If we can take case 2, if reverse means rho is less than sigma, then Vt would be negative, and so the object will move up. And third case, if we take rho is equal to sigma, then Vt would be 0. Then object neither goes up nor comes down, which means it floats, it halts like kite halts in the sky after certain altitude or height, or clouds float into the sky during rainy season. So these are the few applications. Thank you so much.